So you can join, right? From the workshop batch. Okay. Yeah, hi everyone. So today is the first session. We are going to start the workshop batch, right? So this is the 10 days workshop, right? For system verilog using verification. So mainly I already given the content of the course, what we are going to cover in the day 1 to day 10. So day 1 is mostly on introduction to the system verilog and what a test bench architecture explanation and what is mean by test plan and test scenario or test strategy, and what are the different steps of execution steps for the test case, how the test case will be executed, how can we know whether the test is failed or passed. Okay, so how to debug the system verilog program, how can we debug any error signature. So these kind of stuff today we'll see these things. Okay, so from tomorrow onwards we'll cover the data types and like arrays in the system verilog and like different concepts like interfaces, virtual interfaces, mailbox. So every day we'll cover the topics of system verilog. So finally we'll cover all the oops concepts and randomization and constraints. Okay, so coverage analysis and assertion based verification and the projects. Okay, so this is the 10 days we have scheduled, right? So yeah, today we'll start the session. So if you have any doubts in the session, don't feel okay. So feel free to ask the sessions. We can discuss your doubts. Okay, make the session interactive. Okay, so whatever the doubts you have regarding the session and all, so you can discuss your doubts. Okay, so shall we start our session? Is the screen visible for you, everyone? So mainly this
Yes.
workshop is mainly for practical sessions. Okay, we already told, right? Mainly interview questions. Not we are not starting from the basic things. Okay. After today's session, I will tell you what to go through. Like what are the theory concept you need to just revise. Okay, just understand the things before coming to the workshop, so that we can discuss how we can implement those things in practical way. Okay, suppose oops concept is there, the inheritance concept. So you know the concept of inheritance, right? So how the parent class and the derived class will work. Okay, so those things we are approaching in a practical way in the coding style. Okay, for interview purpose mainly. So mainly this workshop is for practical purpose. Okay, so yeah, we'll start the session. Already I have shared the demo session for you, right? Two demo sessions, two parts. So in that demo session, we already discussed something recollected on Verilog and what is the purpose of verification and verification approach in the VLSI. So why we use the system Verilog rather than Verilog? What is the need of system Verilog? The synthesizable constructs of system Verilog and non-synthesizable constructs, and what are the features of system Verilog and test bench environment. All these things we have seen, right? So can anyone tell what is the purpose of the verification? Why we need to do verification in the VLSI? What are the different
To
verification domains are there in the VLSI? Yes, yes, please go on. You can unmute your system and you can talk. What is the purpose of verification mainly? What is the intention behind verification? No idea?
Hello,
Hello.
hello.
Yeah, hello.
Yes, I'm audible, ma'am.
Yes.
Basically, The verifications can be done because the functionality verification of that particular block or IP map before the design is can be sent to the foundry, so that we can be identify the each and every cases can be work properly or not before the it can be implemented in the on the chip map. So because that reason we are doing the verification before sending the design to the foundry.
Okay, good. Okay. Any other answers? Okay. So mainly in our VLSI, the design verification in the VLSI plays a crucial role. Okay. And to verify whether the product or the system design has met its specified standards and the requirements are okay, and also how the timing constraints are working with the specific with the specification, okay, with the design. Okay, so how much percentage of verification we did our design. Okay, what is the coverage analysis? We can get the coverage report. Okay, coverage report is nothing but how much spec has been verified. Okay, so this is the main purpose of the design verification. Okay, based upon the test cases, okay, test results, we can verify our functionality. Without verifying the functionality, we cannot send to the physical design. Okay, because we don't know whether our functionality meet our standards or not. Okay, maybe they have some error in the synthesis. If there is no error in the synthesis, maybe some functionality error will be there. Okay, which are not reaching correct output for all scenarios, for every scenarios, for corner cases also. So once we do the verification, the result will be either pass or fail, so that we can proceed for the next step. Okay, that's why verification is needed. Without verification, if we send our synthesize, okay, whatever the design synthesizer design is there, if we send directly to the physical design process, okay, so once physical design completed, if the chip is not working properly, that is the wastage of time and the product cost. Right, that's why verification, design verification is very mandatory step in the VLSI. Okay, not only in the front end. Okay, we have different domains in the VLSI, right? Front end VLSI domain and the back end VLSI domain. So every step we do the verification. After designing the RTL, okay, after getting schematic of RTL, we do the design verification using UVM methodology. And in the backend process, okay, so after testing, after physical design, there also we do the testing validation of hardware. Okay, so every step we do the verification. Without the verification, we cannot move to the further step because we don't know where we get the error. Okay, where the error will be occupied, we don't know. So for every step, verification is needed. Okay, without verification, directly we cannot proceed for the next step because it will be depend on the time constraints and the mainly time, which is very efficient, right? And also cost. And verification approach in VLSI. Can you tell me, have you gone through the demo session, everyone? If you don't seen the demo session, okay, if you are not aware with the demo session, I already shared yesterday only. So if you are not aware with that, okay, please go through that sessions today. Okay, because I'm not covering those again. Okay, because in place of that, we can cover some more things, right? So that's why I'm not covering those things. So we already covered these things in the demo session. If you don't aware with that, just go through those sessions first of all. Okay. So yeah, can anyone tell the verification approach in the VLSI?
Verification approach means verification plan.
Hmm. So how we develop
Well,
the verification plan?
design and the verification plan, and according to the design and its specification, the verification engineer make the verification plan, then the manager will approve that plan after seeing the verification design and verification plan. Then it goes to design engineer, then verification engineer, then test case engineer. Similarly, like they will check the test coverage of the, like, design all the specification, and then like this, I think.
Okay, good, good. Any other answers? Okay, yeah, that's fine. So, yeah. So why system Verilog use it for verification rather than Verilog? Why we are not using the Verilog for verification?
Actually, Verilog, system Verilog has more features than Verilog. That's why we use system Verilog for verification purpose, because like features like constraint randomization.
Okay, yeah,
Ma'am, in system Verilog, we have a class features like class objects, polymorphism, abstraction, and then these all feature like mailbox, and also we have a dynamic memory in the system Verilog, and yeah, randomization we can, like, in Verilog we have to do randomization one by one, but in system Verilog we can directly randomize a whole class. So there is, like this, there is many more advantage
yes.
for system Verilog over
Yeah.
Verilog.
Yeah. So Verilog is not much suitable for the IP level verification, okay, or SOC level verification, or any like some complex projects also. Verilog is not efficient, okay. It doesn't have particular features, okay, like OOPS concepts. In system Verilog, we have class-based verification. Class-based verification means in terms of, if you see, if you want to access any variable from the transaction class, using the Verilog, how can you randomize any variable? We need to, if there are 10 number of variables, for every variable we need to use the $random. Okay, separately we need to do the randomization. But whereas in system Verilog, by using the OOPS concepts and classes and objects, okay, we can randomize it. We can randomize all the transaction class variables at a time. Okay, using the single line. Okay, that is the one advantage. And randomization and the constraints is also the good example, the good feature in the system Verilog. Okay, we can write the great constraints in the system Verilog. Okay, different type of constraints are there. And also the coverage analysis, which of the very important concept. Okay, coverage analysis and assertion based verification for design and verification. That is also one of the best feature we have in the system Verilog. That's why we are using the system Verilog for the verification than Verilog. Okay. So, and what is the need of system Verilog? You know all these things, and we'll move to the next slide. So, coming to the day one content of the workshop. So, first is what is system Verilog and evaluation of system Verilog, from where it got evaluated, like the evaluation, the history of the system Verilog, and the test bench components, architecture, and what is the difference between test plan and the verification plan. Okay, and the difference between test case, test scenario, and test strategy, and how to create the test plan, how to debug the test case, okay, and how to execute a test, and how to know whether the test pass or fail, and what is the checking mechanism, what are the different stages involved in the test case simulation while running the test case, what are the different execution steps involved in the test run. Okay, so these things we are going to discuss, all are the basic things, okay, because as a verification engineer, first we need to know about the test scenario. Okay, before going to the components and architecture, writing the code and all, first we need to know the basic concepts regarding the test bench or test scenario or test cases, how the test executed. Okay, so that's why day one session is for these content. Okay, so yeah, let us start. So what is a system verilog? We already know system verilog is a standardized IEEE in 1800. It is came from hardware description language and hardware verification language. It is used to model the design and simulate and implement the electronic systems, like mainly for design verification. Okay, it is a unified language for the design verification, and also the language which is support for all verification methodologies like constant random coverage verification, assertion based verification, and functional coverage, toggle coverage. Okay, and which supports the object oriented programming. So system verilog is based on Verilog and some extensions. Okay, if you see the extensions, so this is the evaluation of the system verilog. So if you see Verilog in 1995, which is created in the 1984, so there we have only the modules, okay, like some of the system tasks like dollar finish, dollar display, dollar monitor, dollar write. Okay, so then in the Verilog 2001, we have some like local param, okay, like standard files regarding IO and my multiple dimension arrays. Okay, in starting we have only single dimension array. Then in Verilog we are seeing multi-dimensional array. But now in system Verilog we are looking different arrays like static, dynamic, associative arrays. Okay, so all of these are the advantages coming to the system Verilog. Okay, so mainly system Verilog extensions came from like number of sources, not only from the Verilog. Okay, it is using from C and C++. Okay, like the data types and object oriented programming, all these came from C and the C++. Okay, assertion based verification, we are telling that assertion based verification, that is from PSL. Okay, there is a OpenVera which is for randomization and the constraints. And from the VHDL, we have enum packages and all, right? So all these things, from all these things, the system Verilog has developed as a unified language. Okay, so that is very benefit. So if you see the special features of the system Verilog here, like assertions, and it have the coverage analysis, so test program blocks, clocking domains. Okay, in the interface we have the clocking domains for more synchronization between the design and the blocks, the components like a driver and the monitor. Okay, for that specifically we have the clocking domains and different type of arrays. Okay, and like if you see the communication purpose, the mailboxes and the semaphores, so these are the main advantages we got in the system Verilog. Okay, so everyone understood up to now here?
Yes, ma'am.
Okay, okay, if you have any doubts, please let me know. Okay, so coming to the system Verilog test bench architecture, you already seen the system Verilog test bench architecture in the demo session and the implementation using the example also, the 4-port calculator. Can you explain anyone what is mean by generator, driver, and monitor, scoreboard, how the execution happen between these, like hierarchy?
Yes, ma'am.
Yeah.
Yeah, first of all, like we create a transaction class in which all the data, like input, output ports will be there. After that, generator basically used to send the data, all the input data.
Yeah.
Fetch that.
Yes, yes. Carry on.
Then data to the DOT using the interface, like virtual interface. And like driver two purpose, like first we take the data from the generator and send data to the DOT using a virtual interface. So DOT DOT get the inputs and work according whatever the functionality it has. After that, it send data to the monitor using the virtual interface. Then monitor takes the data similarly like a put method and send data to the scoreboard via mailbox and scoreboard, and the scoreboard receives data via mailbox using get method, and then the reports generate like comparison, all the verification I think done.
Yeah.
compare the reports and generate the reports. I think
Okay.
this is the flow.
Yeah. Okay. Okay, that's good. So if you see everyone, here we have different components. Okay, all components are derived in the class based only. So every component is defined in a class. So here, if you see the transaction, first of all, the transaction means here we define all the pin level activity. Okay, whatever generated by the agent will send to the DUT, like through the driver. Okay, the driver is used to drive all the transaction data into the DUT. Okay, so mainly in the transaction, we have all the variables, whatever the input variables and the output variables. The input variables need to be randomized, right? So all these data, input and output data will be available in the transaction, like port list. Okay, so next one is a generator. What is the generator? Generator is a class. Okay, it generates the stimulus, like it create and it do the randomization of the transaction class and it sent to the driver. So that is the generator. Mainly it uses for generating the stimulus by creating the randomization and it will send to the driver. And next one is a driver. Driver means it receives the data from the generator. Whatever the generator generated the random data here, the driver receives the data here. Okay. And it will send to the DUT via interface, via virtual interface. Because here interface is a static in nature, whereas a virtual interface, because all these classes are dynamic in nature, right? Because we are class means it's a dynamic in nature because it's all using the object oriented. Okay, so for that purpose, interface is not used practically. So by using the instance of interface, we are creating a virtual interface, and through the virtual interface, we are making the connection between the driver and to the DUT. Okay. So another thing is a monitor. Monitor means it will capture all the data, the pin level activity sent to the packet level by using the monitor. It will get the data from the DUT or total input and output data. Okay. And from the monitor, it will send to the scoreboard and it will send to the coverage analysis and it will send to the reference model. Okay, like that. Okay, scoreboard means here we'll check the logic. Okay, logic in the sense like we'll do the we'll check like if you see in your BTech or MTech, there will be like laboratories, like we'll check our practical value with our theoretical calculations, right? So like that in the scoreboard, we'll generate some logic for the design. Our original design will generate some logic in the scoreboard which calculate like a theoretical calculation. Okay, we'll check our expected output to the this theoretical calculation, like some golden reference value, the logic. Okay, so scoreboard is mainly used to check like checker. Okay, so which checks the expected output to the whatever the logic we used in the DUT, sorry, in the scoreboard regarding DUT. So mainly it is used like a checker. So if you see, while sending the random data from the generator to the driver, here we use one communication mechanism like mailbox. Okay, a mailbox is like a communicator between the generator and the driver. So what is mean by mailbox means just it is like one type of array. We use one type of array which stores the data for some time. Okay, so the communication between the generator and the driver. So by using the put and get methods, if you see the demo session, you will get understand like how we use the mailbox, right? So that's the purpose of mailbox here. And all these four the three components will connect in the agent. Actually, agent is not specified in the system Verilog. Mostly agent we use in the UBM. It is a one transaction layer. So agent is mainly used in the UVM. Okay, not for system Verilog mostly. And next, environment. Environment is the top module for all these four components. We specify all these four instances in the environment So from the environment, we'll call all the 4 instances here. Okay, so this is the hierarchical model, and the test, in the test will define the environment, and test bench top. In the test bench top will define the test and the DUT. Okay, this is how we'll connect the system Verilog test bench architecture. So whenever you are writing a simple test bench, whatever, it's a simple program, it's a simple design or the complex design, whatever, you need to follow these steps. Okay, you need to follow these steps. Everyone understood?
Yes, ma'am.
Everyone understood?
Yes,
Do you
ma'am.
have
Yes,
any
ma'am.
doubts? Do you
Yes,
have
ma'am.
any doubts? Okay. Okay. I'll just show you a simple example. Just a second. Just I won't give the brief explanation of the program. Just I will show you how the structure, how we connected the structure. Okay. So if you see the example here, it is a FIFO. Okay, it is a FIFO example. So first in, first out. So how we have taken here, first generator. So if you see the generator here, we have written the class generator. So class, name of the generator is the class generator. Here we have taken the transaction. Ignore the 3 transactions here. Just we can take single transaction also. And just if you see here, we are doing the randomization for the transaction. Okay, tr dot randomize. So what is the tr here? What is the transaction? First, we need to check for the transaction class. So if you see in the transaction class, what we have written, class transaction rand c. So rand is for randomization. Here WR is the write data, read data, reset, data input, data output, write pointer, read pointer, FIFO counter, full empty. All these variables are the inputs and the outputs. Inputs must be declared with the rand because we are doing the randomization. Okay, we'll discuss more detail in the concepts. Okay, and then we just define some constraints regarding the FIFO. Okay, to hit the coverage report more and to get all the scenarios. Okay, to do the verification for all scenarios, we written different type of constraints. Okay, so this is the class transaction. If you want to do the randomization in the Verilog, okay, so what you need to do? You need to do for WR equal to $random, read equal to $random, reset equal to $random, and that too we cannot control the randomization here. In the Verilog, we cannot control. That means we cannot put the specific values for the randomization. But here we have the constraints to put the specific values. Okay, that is one drawback for the Verilog. So whatever we are defining the data input variables in the transaction class by using a single object. So if you see here, how we are here, we have created the transaction instance. Okay, instance means object for that particular class dot randomize. So when you are doing tr dot randomize, what happens? Whatever the input variables are there in the transaction class, all the input variables will be randomized. Okay, so the generator is doing randomization, and if you see 52 line, it is putting into the mailbox. Okay, G2D is the mailbox, so it is sending to the mailbox. So from that mailbox, we are accessing to the driver. Okay, so this is the class driver. We have created the virtual interface, and after creating virtual interface and also created the mailbox. So from here, if you see 28th line, get method, there is a get method, right? So by using the get method, we are getting the data from the mailbox, and we are sending to the DUT. So what is this here? So whatever the data is there, tr dot write, okay, tr dot write, tr dot data input, tr dot read data, all these data we are sending to the DUT. DUT of write read data using the virtual interface. We'll explain all these things in detail, but I am telling just overall. Okay. Next, next receiver. Receiver is the monitor. Okay, from the monitor we are just taking one virtual interface and the mailbox, and whatever the data we have in the DUT, all the data we are sending into taking from the DUT and sending to the transaction class. Okay, so this is the DUT signals pointing to the DUT and sending to the transaction class. Okay, so from that we are sending to the mailbox, because to send to the scoreboard we are sending to the mailbox. So from the mailbox, so scoreboard, from the scoreboard we'll access the data from the mailbox. There in the monitor we use the put method, so here we are using the get method, so that we can get the data from the mailbox in the scoreboard. Okay, so can you please join for the next session? It is actually 40 minutes limit. Okay, with the same link, please join again. With the same link, please join for the next session quickly.
Yes.
ma'am.
Yes, ma'am.
Okay, so from my side, a small request while I am discussing, please concentrate here. Okay, because of live sessions, if you miss somewhere, it will be like disconnection will be happen, right? Again, you cannot get like what we are discussing. It will be confused. Okay, so while I'm discussing, just be focused here so that you will get the concept clear. Wherever you don't understand or you are not able to capture that information, like that word, you can ask again. Okay, we can discuss detailedly. Okay, so here it is the scoreboard. So what we are doing in the scoreboard, we are creating one mailbox and the transaction tier. So whatever we have kept in the mailbox in the monitor by using the put method, from that mailbox we are getting all the data in the scoreboard. Okay, in the scoreboard. And what we are doing here, this is the logic. This is the logic. So what we are writing the logic according to our FIFO design, we need to check the logic. Okay, so what is the logic here? tr.read. So if memory tr.read pointer is not equal to tr.data output, because actually in the FIFO we have the read pointers and the write pointers, right? Based upon the read pointer and write pointer, we can store the data into the locations. Okay, so like that it is checking for the read pointer and write pointer, and also we have the empty and full conditions. Okay, so based upon that we can write the logic. Okay, how we can check our expected output and how it is generating from the golden reference value. Like that we can check the output. Okay, so for that purpose we are writing the logic and we are writing the expected output. If expected output is same with the actual output, then our test is pass, otherwise test is fail. Okay, so like that we can check the nothing but checker. Okay, scoreboard is nothing but the checker. Next, after these four components, what is the next component? That is the environment. Okay, so environment means here we include all sub components like transaction, generator, driver, receiver, scoreboard. All the sub components will be included here, and we'll create the instances for those. Okay, and we'll run those from the environment. So if you see here, G is equal to G means generator is equal to new. So we are passing the arguments here, because generator we have, when we are creating the class, we have the constructor only the mailbox argument. But for the driver, we have the two connections. This is nothing but connections. Okay, for the driver, we have the connection with the, if you see here, for the driver, we have the connection with the transaction and also, sorry, mailbox and also DUT. So two connections. For the generator, we have only one connection, mailbox. For the scoreboard also, we have one connection, mailbox. And for the monitor, we have two connection. One is the mailbox, another one is the DUT. Okay, so that connections we are creating while we are creating the class. Okay, so for that purpose, in the environment, while you are calling those classes, we are passing the arguments here. Okay, so yeah, and then top level is a test. In the test, we call the virtual interface. We call the environment, mainly environment. Okay, so actually this test is somewhat complex. So E is nothing but environment. Okay, so here we are calling the E dot G dot main, which is pointing to the generator. Okay, E, from the E we are pointing to the generator G. From the generator, from the G we are pointing to the main task, like this. Okay, so from the test we call the environment and submodules, and the test bench. In the top level test bench will connect our DUT and the test. Okay, so this is how we connect the interface and the test and the DUT in the test bench top level. So these steps are mandatory for every program, and the functionality wise we can change. Okay, the constraints and the randomization coverage report and the scoreboard logic, everything will be changed with our functionality. Another thing is the interface. So this is the interface we write. Interface for the FIFO. So in that we'll write all the inputs and outputs. So if you see here, the logic variable, what is mean by logic? Can anyone?
Logic is a data type. Is like in Verilog, wire and range are there. So, but in system Verilog, logic is alone work as a wire and range. Like we can define input and output both in the logic. Basically, like concurrent and parallel blocks in system Verilog removed.
Okay, okay, good.
So, yeah.
Okay, so any other answers? Okay, logic is nothing but in Verilog we have the reg data type and the wire data type, net and register data types, right? So what is the disadvantage with that limitation? Limitation is nothing but register data types are used only for the procedural blocks, and net data types are used for continuous assignments. Okay, so while we are connecting our test bench to the DUT, there arrives some confusion. So to avoid that confusion, in place of procedural and the continuous, we are just taking the logic data type here. The logic will replace the reg and the wire. So there is no confusion while we are connecting whether inputs or outputs. Okay, so mainly that is the logic data type, which is used in the interface, because we are interfacing our DUT to the test bench, right? So that's what. So this is the architecture, how we the test bench, how we use for the system Verilog for any program. Already in the demo session, we discussed for the 4-port calculator very clearly. So that's why I just explained very quickly here. Okay, so did you have any doubts, anyone? Did you have any doubts?
No, ma'am.
Okay, so here system Verilog architecture has completed. And next one is difference between test plan and verification plan. So what is the difference? What is the difference between test plan and the verification plan? Any idea?
No, ma'am.
No, ma'am.
Okay, okay. So in the system Verilog or any verification, okay, system Verilog or UVM or SOC level verification, mainly we use the C or C++ for SOC level verification. So whatever, okay, whatever. So test plan and the verification plans are nothing but the documents, okay, used to plan and organize the testing for a design. Suppose for there is a design, okay, so for the design there will be different scenarios will be there, different features will be there. So how we will design a test case for each feature, okay, how we are going to verify the scenario by using different test cases, how we are going to create the test cases which are able to verify those particular feature or those particular scenario. Okay, for that we are taking one test plan. Plan is nothing but just planning, okay. Suppose if you want to construct a house, we'll take one planning, right, for every room where we need to construct, okay. So for every house there will be house plan. Like that, here for our design, what we are going to verify exactly, okay. For that purpose we are taking one plan is nothing but test plan, okay. So the several there are different purposes there, okay. There are different purposes and we have different focuses on test plan and the test verification. So mainly if you see a test plan, which is nothing but it describes the overall approach of testing a design, okay. So mainly it includes the objectives means the specific goals of the testing, like such as a functional coverage or related to the performance, okay. The main objectives, okay, based upon the specification goal. And test cases, what is mean by test case? Test case is nothing but suppose there is a feature. In feature there will be different scenarios like reset operation, okay, like clock mechanism, or some handshaking between the master and the slave, or register read write operation, okay. These will be different scenario. When there are different scenario, how we will test those scenarios? By using the test cases or test scenario. So everything we are dealing in the project level, right? So there will be test cases. By using the test cases, we will verify those features, okay, those scenarios, okay. So yeah, test cases means it will verify the design. So each test case have a set of input stimulus, expected outputs, test fail, or different criteria, okay. And coming to the test environment, what is mean by test environment? For both software and hardware components, it is required to run the test such as a simulators, okay, like test simulators or test benches, okay, test methodologies, okay. Every environment will have these things. That is nothing but test environment, whether it is a system Verilog environment or UVM based or C++ based, okay. So like that. And next one is test methodology. So this is the approach for running the test, such as the random testing or directed testing or constant random testing, okay, by using different methodologies. And next, test metrics. Mainly it measures the evaluate like effectiveness of the test, okay. Effectiveness of the test means from where we get the effectiveness of the test. Nothing but the code coverage, functional coverage, toggle coverage, fault coverage. Based on the coverage report only, we can know that how effectively our test case is working. Is that correct? From the coverage only, we can achieve the how the test case is working effectively. If coverage report is 50%, how then what is it mean? Nothing but our test case is covering only few number of scenarios, only 50% scenarios. So to hit other bins or to hit other functionality, overall functionality, okay, to get 100% coverage. So how we can modify our test case, how we can modify our functionality, how we can get different scenarios. Okay, so that will be dependent. Test matrix is nothing but getting the effectiveness of the test bench. Mainly test. Okay, this is the plan we need to make. Okay, plan in the sense how many test cases are there, what is the environment, and what is the coverage report. Okay, what is the assertion report, everything we'll check. That is the test plan. Then what is the verification plan? What is meant by
Ma'am, could you
verification
repeat?
plan? Yes, tell.
Could you repeat test environment again?
Test environment is nothing but like how the components, like required components wherever we are running in the simulator, like such as simulators or some test benches, what type of verification environment we are using. So that is the test environment.
Okay, like on which like simulator we are running
Yes,
the whole
yes,
test.
different types of simulators we have, right? Like VCS or Synopsys tools or Cadence or Verdi. Okay, different environment is there. So the approach how we are taking different simulator approach like that.
Okay, ma'am. Okay.
Okay, so next, verification plan. What is mean by verification plan? It is also a same as a test plan, but not same. Okay, so test plan is mainly it is approach for testing a design, right? But here verification plan is a document that describes the verification, like the specific design module. Okay, like it includes the functional specification, and functional specification means it give the detailed explanation of the expected behavior of the module of the design. Okay, it will give the expected behavior of the design, which is under test, design under test, nothing but DUT. And next one is a verification objective. So what is meant by verification objectives? Mainly the specific goals of the verification, like as functional coverage, performance. These are the main objective. So these things will get. And verification methodology, same like different testing, like directed testing or constraint driven randomization testing or random testing, these things. And verification environment, like such as simulators or test fixtures or test benches. Okay, different things. And test cases, same whatever we have discussed previously, but here one thing is added, like functional specification, which give the detailed explanation of the behavior of the DUT. Okay, so that is the verification plan and the test plan. So moreover, test plan is a high level document that describes the overall approach of the testing of the design, whereas a verification plan means it will give the specific design module, the specification of the design module. Okay, everyone understood?
Okay, ma'am.
Next, what is the difference between test plan and test strategy? Who will design the test plan and who will design the test strategy?
I think managers only.
Okay. Okay, so test plan, suppose test strategy is nothing but like the managers. Okay, test managers will make the test plan, whereas the responsibility of building the test strategy is of the project manager mainly. Okay, so at the project level, you need a test plan. On other hand, the test strategy you need at the organization level. Okay, from the organization, they will give the test strategy. Okay, main for the specification related, like for every project we won't have the old test cases, we won't have the old test features or test scenarios. For every project there will be updated test features will be there, right? For every generation or every version, like if you use the mobile phone, whatever the mobile phone, for every mobile phone for every version we are getting some updated features, right? So that's why they won't use for all cases, they won't use the old test cases. Maximum 70% they use the old test cases only. But whatever the specific features are upgraded, so for the features they need to create the new test cases, right? So for the test strategy is required. Okay, the manager means in the team there will be a team lead, right? First, team lead will create the test plan. He cannot create the test strategy, he or she. So why? Because he don't know everything about the feature. He may know, but that need to come from the officially high level organization, right? So test strategy is like organization manager or the main project manager. Okay, from the project manager, the team lead will develop the test plan. From the team lead, the remaining engineers will work on the test cases and debugging these things. This is the flow of the verification strategy. Okay, so that's why that is the difference between the strategy. Mainly the test strategy explains how the testing part needs to be completed. Okay, because there will be 100 number of features. Every suit or every team, there will be several features will be there. Okay, so they need to need to give each feature to the specific team, and so these things will be taken by organization level. Okay, so that is the test strategy. Okay, everyone understood here?
Yes, ma'am.
Yes.
Okay, so next one is a test scenario. What is mean by test scenario? What is mean by test scenario?
The
Don't you
possible
have-
Defines functional tree.
Okay.
yeah,
Okay.
test scenario basically the possible operation of any.
Mhm.
It is basically possible operations.
Okay. Okay, see. So as I told that in the test strategy, there will be different test plans. In the test plans, there will be feature wise different features. Okay, because in the test plan, suppose you take one particular team. Okay, suppose the DFT team or some debug unit team. Okay, so in the team there will be sub teams, sub components or sub suits. So each suit have different features. So those features will be defined in the test plan. Okay, so if you take one feature in the test plan, suppose in the test plan there are 10 number of features. Suppose here we discuss the test plan, right? So in this test plan, there are 10 number of features. Okay, what is mean by feature? Like one feature is like debugging between the microprocessor to the IOD, or microprocessor to the memory unit, making the accessing mechanism, or the sending the register level, checking for the register level storage. Okay, like accessing the registers. So different scenarios will be there, like clocking mechanism, or sleeping test cases, which are power down mode or power up mode. Okay, so these things will be there. So these are the different features will be there. Okay, related to the clock or power down or reset modes, like this. Okay, so in the test plan there will be number of features. In every feature there will be different scenario. Okay, there will be different scenarios. So that scenario is nothing but test scenario. So test scenario consists of detailed test procedure. Okay, we can also say that a test scenario has many test cases associated with it. Okay, because suppose if you take one test scenario, what is the test scenario? Here I have a master. Some masters are there, like MP1, MP2, MP3 masters, which are microprocessors. From the microprocessor, I want to establish the connection to the memory or any some debug units. Okay, so I want to do the read write operation between the microprocessor or handshaking mechanism between the microprocessor to the memory or the debug unit. This is one feature. I want to verify this particular feature. So how many test cases I can develop to verify this particular feature? That depends upon the team members. Okay, so that depends upon the team, like a test feature, and how many test cases we can develop to hit the 100% coverage for every scenario. Corner cases also we need to check, right? So in the test scenario, to verify that particular feature, we will develop the test cases. Did you understood now, everyone?
Yes, ma'am.
Okay. Okay, is there any doubts? So if you see, test
No.
scenarios consist of the detailed procedure. We can also say the test scenario has many test cases. Before executing the test scenario, we need to think of the test cases of each scenarios. Okay, whereas test cases are the set of steps to determine the execute the scenarios in order. Okay, so next, test case. So what is mean by test case? Test case is nothing but test cases or low level actions that it can derive from the test scenarios. Test cases are set of steps which perform the system to verify the expected output. Okay, in the test case, we have different scenarios. Okay, so by using those scenarios, we will expect some output for that particular feature. Okay, so test case mainly consists of the test case name and like conditions, some conditions or some input conditions and expected results like that. Okay, and test cases are like low level actions which is derived from the test scenario. And test case will give the detailed information about like what to test and how to test and the expected result. Okay, and mainly test cases are like mainly to verify the result. Okay, test cases are more important where developing different outputs. Okay, so that is the main test case. So if you see the difference between test scenario and the test case, suppose there is a reset mechanism. So for doing the reset or for checking the reset operation between different masters and slaves, okay, there are n number of masters and n number of slaves. We are developing 5 number of test cases. And access mechanism between all masters and the slaves, like masters like any master like microprocessors or like core. Okay, ccd configuration, we have ccx configuration, like, right? So whatever the masters, whatever the slaves, we are checking the access mechanism. Access mechanism means read or write operation between the registers. Okay, so we are, for that purpose, we are writing the 10 number of test cases or maybe 15 number of test cases, and handshake between the two units or any two suits or any two IPs or two components. For that, we are doing the test cases. We are developing some test cases. Okay, so this is the test scenario and the test case. Everyone understood?
Yes, ma'am.
Everyone understood, or do you have any doubts?
No, ma'am.
No, ma'am.
Okay, that's good.
No, no, ma'am.
Okay, so yeah, that's good. So next one.
Ma'am, ma'am, how test strategy and
What?
scenario like related?
Sorry.
Test strategy
Hmm.
and test scenario, like within test strategy, we just make the test plan. After that, within the test plan, we make the test scenario, then test cases, like this only.
Yes. Yes. Yes.
Okay, then.
Okay. So
Yes,
how
ma'am.
the test is executed, whether it is a IP level or SOC level. Okay, how the test is executed. Can you tell me the checking mechanism? How you will check whether the test is pass or fail? How will check whether the
Ma'am,
test is pass or fail?
if it's like if the output will be expected output, then that the test case is pass. If the output is not as expected according to the specification, then the test case will be failed.
Yeah. So pass or fail means actually we need not to check. Okay, automatically in the VCS run.log file, we'll get the test passed or test failed. Okay, if you see in the SOC level verification, okay, we'll talk something on SOC level verification. So every suit we have 50 number of test cases. Another one point you need to remember is test case is a one-time development. Okay, one-time effort. Every time we won't develop the test case. Okay, suppose if any functionality is not matching, like any errors is there, okay, like the functionality is not correct, then we will change our test case. Otherwise, we won't change the test case every time. Okay, it is a one-time effort. Okay, so in the SOC level, there are 50 number of test cases in the particular suit, whatever IP. Okay, there are 50 number of test cases. So in that 50 number of test cases, I want to run. Okay, I'm doing the run. So I want to check how many test cases are failed and how many test cases are passed. Suppose here 23 number of test cases are passed and remaining 27 test cases are failed. So how we need to know the test pass and how we need to know the test is failed. Every time we check our, like in the SOC level, IP level verification, we cannot check like values. Okay, here in our projects like that, we'll check our read or write values like that, right? So there we by default will write some statements. Okay, so here also we'll write some statements, but here we can check very easily, like we are using the normal tools, right? So we can check very easily without no need to check for all different files like a test execution files or VCS run.log files or some C++ programming files. We no need to check all the things. Okay, so first we'll discuss how the test is executed. Okay, so I want to run these 50 number of test cases. How can I run the number of test cases? There will be a make file. There will be a make file. In the make file, we use the scripting language, whether it is a Perl scripting language or Python, whatever. Mostly we use the Perl scripting language. By using the Perl scripting language, in the make file, we'll put like what is the test case, what is the suit name. Okay, so what is the verification, like which implementation name it is using, whether C++ file or UVM dot file. So these all things will put in the make file. Okay, so run commands also will be there. So by using the run command, okay, we run the test cases, one test suit. In the test suit, there will be number of test cases. So once we run the test, first it will check for the failure. Every time it will check for the failure. Okay, whatever the first failures are getting, that is the compilation errors. Okay, if the test is failing immediately within 1 hour, 2 hours, that will be the compilation error. Mostly first errors is the compilation error. What is mean by compilation error?
Syntax error.
Yes. So syntax errors, okay, like if there are any missing, like the comma or any spelling mistakes or like syntax errors. Okay, so first it will get the syntax error. Once syntax errors are cleared, once compilation free, it will enter into the initialization steps. It enter into the main test execution. Okay, so initialization steps means different stages will be there in the initialization stages. Okay, what are the different initialization stages we have? Like reset state. Okay, So first of all, the system will go to the boot up. Okay, boot up sequence. Okay, we have system management boot up. Okay, so once boot up clear, it will go to the power up reset, and it will release the cold reset. Okay, it will load the fuse. Okay, different SMN fuse or different system management fuse, and it will check for all fuse initialization within the components, and it will go to the hard reset. Okay, hard reset mechanism, and it will exit from the internally. There will be different hard resets and boot code, everything will be there. So after all this checking, okay, so clock initialization, and it will check for clock initialization, and it will enable the cold resets. Okay, so power control, memory power control, and so everything. Okay, after all this initialization, maybe we will get the sometimes the test will be failed in these initializations also. Okay, so once all these initialization clear, it will enter into the main test. Okay, our main functionality will write in the UVM or C++, right? So it will enter into the main sequence. In that, it will check all the functionality. Okay, so anywhere it may get the error, right? If the functionality is not matched with different cases. So there we will find the pass or fail. So automatically the test will be fail. We have the database. Okay, while running the commands and all, we'll get once a database. In the database, we'll see the test pass or fail. Okay, so this is the main test execution. So from that VCS run.log file, we'll see whether test is fail or pass by running the regressions. Okay, so yeah. So like that, we check all the things where if test is pass, okay, well and good. If test is fail, we'll check the sub files from where the test is failing. Okay, from in the initialization steps, whether it is failing, or in the main functionality is failing, or so many files will be interconnected, right? Different files, different from different suits, different teams, the files are interconnected. So we'll check all those things. Okay, so that is the test execution checking mechanism. Okay,
Ma'am,
everyone here? Yeah, tell.
can you please explain again the content inside Makefile?
In the make file, we have mainly the test suite name and the test case name, the function, like whatever the related database. Mainly we have the suite name and the test case name. Okay,
Suite name in the
Ma'am,
sense?
the configuration, we have the configuration names in the make file, and some script commands will be there.
If you have any screenshots, can you share them? It will be
Okay, I will share later. Okay. Okay, so
Ma'am,
this is all about today's session.
what, ma'am,
Yeah.
what is under like cross initialization? Like initialization.
Did test has crossed the initialization stages or not? I told you right now all the stages, like power down, like power up, hard reset, cold reset, fuse checking, boot code, all these are the initialization stages. Once all these stages are crossed, it will enter into the main test sequence. Okay, so that's what we can check. This is the test execution happens. This is how the test will be executed. Okay.
Okay, ma'am.
Okay, then
Ma'am,
yeah, tell
we
fast.
will get a PDF. This
Yeah,
one.
I will share you the PDF, and I will share you the system verilog materials also, everyone, and assignment. I'm thinking from tomorrow I will share the assignments. Okay, so yeah, if anyone not gone through the demo session, please go through the demo session, and I will tell you what you need to see before coming to the tomorrow session. Okay, so I will let you know in the group. So whatever we are discussing, please strictly follow, so that within the 10 days you will get everything related to the system Verilog in the advanced level. Okay, so please concentrate the thing. So yeah, if you have any doubts, please you can message on the WhatsApp, or tomorrow we can discuss. Okay. Okay, then thank you
Okay,
everyone.
ma'am.
Okay, ma'am. Thank you.
Thank
Thank
you.
you.
Yeah.